All right, here we go. Question number 15 from our 13-16 homework number 2 in MyLab Math. Find the amplitude, period, and the phase shift of the function, graph the function, and some more stuff. Okay, so here I've got the function copied down over here. The first thing that I want to do is I want to write the standard form of a sine function below it. And the standard form is y equals a sine of bx plus c. That is the standard form of a sine function where we can now see the value of a. A is -5, b is -3, and c is pi over 2 at the moment, okay? But this right here, yeah, this is a problem, okay? So this is where I got to say, warning, danger, Will Robinson. Anytime this value of b is negative, you're going to have to deal with that because b has to be positive. So let me show you what we're going to have to do in order to get that b value to become positive, okay? So we're going to have y equals -5 sine of, and what we're going to do is we're going to take the angle. The angle is -3x plus pi over 2, and we're going to factor out a negative. We're going to factor a negative out of this binomial. So that's going to make the -3x become positive. It's also going to make the pi over 2 become negative. Okay? I'm going to have to factor that negative out. Notice now so that the b is positive, okay? But now I've got to go back and remember my even and odd properties for trig functions, okay? Because if you look at what we really have here, we've got y equals -5 sine of, oh, and that looks like a theta, I'm sorry, sine of -theta, where all of this now is the angle, and it's like sine of negative angle, -theta. So what does the even odd property say about sine of -theta? Well, it says sine of -theta is the same as negative sine of theta. So then we would need to rewrite this as negative -5 sine theta. That's the even and odd property for sine. It says if you have a negative angle, that negative is going to come out front. And of course, a negative and a negative now make a positive. Okay, so all of that to say that now our equation is going to be y equals +5 sine of 3x minus pi over 2 once we deal with the fact that b was negative. Okay, so anytime b is negative, again, I got to flash that warning, danger, Will Robinson. You're going to have to deal with that in order to get the correct equation to graph. Okay, so now we're going to go back. We're going to rewrite that standard form, a sine bx plus c, and now a is 5, b is 3, c is -pi over 2. Okay, and now we can start finding stuff. Amplitude is the absolute value of a, and the absolute value of 5 is 5. So our amplitude should be 5. The period. The period formula for sine or cosine is 2 pi over b. Now b is +3, and that fraction will not reduce. So we're going to leave it as 2 pi over 3. 2 pi over 3. And last but not least, we need the phase shift. Now the formula for the phase shift is negative C over B. And notice that our value of C is already negative. So if I plug that into the formula, a negative and a negative, that's going to make that positive pi over 2 all over 3. B is 3. But then I'm going to need to simplify that. Pi over 2 over 3 is going to simplify to pi over 6. And that should be my phase shift, okay? Pi over 6. Whew, okay, good. I hadn't lied to you yet. Now we're going to go through and graph manually. We're going to take all of this information and we're going to show you how to graph manually using the 6-step method of graphing a sine or a cosine, okay? Step number 1, starting point. Sine starts at the origin. Step number 2, phase shift. And we do have a phase shift. It is positive. So that means that this starting point is going to shift to the right 1/6 of a pi. So we're going to shift to the right 1/6 of a pi, and now that starting point is going to be there. It was at the origin, we had to shift it over. Okay, step number 1, starting point. Sine starts at the origin. If this was cosine, it would start at the A. Step number 2, phase shift. Got to shift that point over. Step number 3, wavelength. The period is the wavelength. And our wavelength is 2 pi over 3. So I've got a question to ask you. Okay, how many 1/6 of a pi does it take to make 2/3 of a pi? How many 1/6 does it take to make 2/3? Well, I think the answer is 4. Because 4/6 will reduce to 2/3. Now, why do we need to know that? It's because that's going to tell me how many spaces to count from the starting point, okay? So I need to go 4/6. I've already gone 1/6. Now I need to go 4 more, okay? 1, 2, 3, 4. So if you look at what I've just done here from start to finish, this is 4/6 because each one of these spaces is 1/6. And I counted 4 of them, and 4/6 reduces to 2/3, which is the period, which is the wavelength, okay? So now what I need to do is I need to count over again to figure out what to label this last hash mark. So we're going to count from the origin by 6th, okay? 1, 2, 3, 4, 5, 6. So this last hash mark should be labeled 5 pi over 6. And that's where this graph is going to finish. Oh, and remember, you always finish where you start. So if I start on the x-axis, I'm going to have to finish on the x-axis. Step number 3, wavelength. Step number 4, 4 spaces. I've got them. 1, 2, 3, 4. I've got my 4 equal spaces. That is step number 4. And so now step number 5 says lay out your points. So if I go back up to this equation here where I took care of the b being positive, we're going to notice that the original coefficient here is positive. And so at this first hash mark, I'm going to need to be up at 5. And then at the next hash mark, we're going to have to return to the x-axis. At the next hash mark, we're going to be down at -5, and then we will return to the x-axis, okay? So that's step number 5, lay out your points. Step number 6, connect the dots. Connect the dots. La, la, la. And that gets us our equation as a wave, and that is one period of the wave. Okay, so what if I need 2 periods? Well, I'm just going to extend this x-axis here, and I'm going to continue to count by sixth. Okay, so if this is 5/6, this will be 6/6, and I need to go 4 of those. Okay, so 1, 2, 3, 4. Continuing the pattern, up, down, down, and up. And that's going to get us another wave, okay? That is another wave. Okay, so let's again count by 6. If we start here at 5/6, this would be 6/6, which is pi. This would be 7/6, 8/6. What is 8/6 reduced? Is that 4/3? So that ordered pair would be 4/3, -5. Okay, 7/6, 8/6, 9/6. But what does 9/6 reduce to? 3/2. So I would expect at the end of 2 complete wavelengths here to be at 3/2, 0. And we can label any of these points. Like if I want this ordered pair labeled, this would be 1/6, 2/6. Okay, but 2/6 is 1/3. And that's up at 5. Any of these can be labeled 1/6, 2/6, 3/6. So if I want this one, what is 3/6? Well, that's 1/2 of a pi. That should be at 0. Again, any of those I can get labeled now that I've got this graph. And what I'm going to do is I'm going to pull up my Desmos, and we're going to check that, okay? Go into Desmos Calculator. And we're going to need to minimize this so I can actually see my equation. Let's see, where was my equation I want to graph? Oh, I actually want to graph the original equation, just so you can see that I'm not cheating by graphing what I changed it to. We're going to graph the original. Y equals -5 sine -3x plus pi over 2. Enter. Okay, so there is my Desmos graph. And then what I'm going to do is I'm going to pull up this graph, and we're going to check some points, okay? So at this point here, that corresponds to my pi over 6 on the x-axis. And then we said the next point, pi over 3, 5, check. Pi over 2, 0, check. And so this is actually verifying the points that I plotted, okay? So let's go to the end of 2 wavelengths. Up and down, and then another wavelength. Up and down. So this point, 3 pi over 2, is where we should end after 2 complete periods, verified. And I can even verify the point before that. 4 pi over 3, -5, verified. Man, Desmos is fantastic. I love it. Now let's finish this off by graphing in MyLab math. And we have a sine wave. So we're going to graph using the sine tool. Just click on the graph. And we're going to change our amplitude. The amplitude was 5. The period was, what was it, 2 pi over 3? The phase shift was positive pi over 6, pi over 6. And notice if I see here in the background, see that is going through -5. So that is going to give us what we would expect for our graph here, okay? So we're not going to reflect it across the x-axis this time, because this is giving us what we need for the graph. So click Save and check. Oh, man, I hope that was helpful. If you have any questions or comments, feel free to leave those in the comment section below, or you can text me. And thanks for watching.